Hi, if you've ever asked how many watts does my home theater need, or will this speaker actually cover every seat in the auditorium clearly, this video will give you a systematic way to answer that based on the acoustics of your specific room. In this video, I'm going to introduce you to the free browser-based audio system design tool by Consonance Acoustics. I'm Amod from Consonance Acoustics. I completed my MS in Engineering Acoustics from Denmark, and this tool is based on the learnings when I was there. The engine behind this tool is the code that I had developed for acoustic calculations, and we have a stellar track record in meeting the acoustical requirements of a space. You will be working with the same engine that has helped us maintain that record. The audio system design part of the tool requires that the acoustical design part be complete. If you don't know how to do that, you can click on the link that takes you to the previous video about acoustical design. The audio system design tool takes in the calculations from acoustical design, as the space details and the RT are a critical part of designing the audio system. Here is something many AV integrators don't account for early enough. The reverberation time of the room directly determines how far your critical distance is, which in turn determines how many speakers you need and where they should be placed. A room with a long RT forces you to use more directional speakers positioned closer to the audience. This is why the acoustic design always has to come before the audio system design. We will work with an auditorium we consulted for in Chennai, Tamil Nadu. I have put in all the details for the acoustical calculations, and here is the RT that we get after applying the treatment. Once you have the RT, click on this button that takes you to the audio system design step. At this point, I must mention that you will have to run this tool as many times as there are configurations. For example, if you want to have a pair of FOH speakers, you need to run this tool with the parameters related to those speakers only one time. But if you plan to add delay speakers, you will need to run the tool again and again with the same acoustical parameters and add the details of the delay speakers. Let me show you what I mean by that. Here is the Sketchup model of the auditorium. You must be wondering what these lines are. These lines are basically the distance lines between the speakers and certain listening positions. We are trying to determine the nearest and the farthest point we intend to use the speaker for. You can see that we have these lines here for the FOH speakers, these here for the delay speakers below the balcony, and these here for the delay speakers for the balcony. You should note that this tool should not really be used for analyzing subwoofers. Now let's begin by designing the FOH speakers. We have a pair of FOH systems, so let's put the number of speakers as 2 here. At this stage, it is alright to arbitrarily put a rated electrical power to see what the results hold for us. Let's see what happens with a 100 watt for a speaker. Now you have to add the sensitivity of the speaker. Speaker sensitivity is measured in decibels at 1 meter with 1 watt of input, written as dB per 1 watt per meter. It tells you how efficiently a speaker converts electrical power into acoustic power. A speaker with 90 dB sensitivity will be noticeably louder than one rated at 85 dB at the same amplifier power. This data is usually available in the spec sheets of the speakers. Let's assume that the efficiency is 90 dB for now. Let's check the directivity now. Q, or the directivity factor, is a measure of how focused a speaker's output is. A higher Q means sound is concentrated in a narrower cone, useful for covering long distances without feeding back into the room. Coverage angle and Q are inversely related. A tighter coverage pattern means a higher Q value. The tool converts the horizontal and vertical coverage angles from your speaker's datasheet directly into Q. A common example of a coverage pattern is 90 degrees by 60 degrees. Let's check what angles are workable for our system. You can check the required angles in Sketchup. Our FOH speaker needs to emit sound between 40 degrees horizontally and 40 degrees vertically. Let's put that in and see what the Q value is. Now let's check the minimum and maximum listener distance. In this case of FOH, the minimum is 7.1 and the maximum is 14.66. Once we have put in all this information, it is time to click on the calculate button. On the results page, you can check the A-weighted sound pressure level at the maximum and minimum listening distances. You can also check the level ranges to see if the difference is not so much that the person sitting farthest will have significantly lower levels than the person sitting closest. You can also check the ALcons, short for articulation loss of consonants, which is a measure of speech intelligibility. It was developed by Peutz and tells you what percentage of consonants a listener is likely to miss. Values below 10% are generally considered acceptable for speech, below 7% is good. In a reverberant space, a poorly positioned or underpowered speaker will push this number up. You can also check the critical distance. It is the point in a room where the direct sound from a speaker and the reverberant sound from the room are equal in level. Beyond that distance, reverberant energy takes over and speech intelligibility drops. In a highly reverberant space, the critical distance can be as short as 2 to 3 meters, which is why speaker placement and directivity matters so much. If any of these parameters fall outside the recommended range, the tool will show them with a warning color, yellow or red. This will help you determine the total configurations of speakers you require. Sometimes you only need a pair of high sensitivity speakers to cover the entire auditorium, and sometimes you may need additional speakers for covering specific areas like those beneath balconies. So to pull this together, the key parameters for audio system design are 1. The SPL you can achieve at the farthest seat. 2. The level variation between the nearest and the farthest listener. 3. ALcons as your speech intelligibility check. And 4. Whether your listener falls within the critical distance. If any of these are outside range, the tool flags it and you can adjust your speaker count, sensitivity or placement. It is now up to you to design various kinds of systems to push this tool to the limit. We are always keen on improving this tool, so do let us know any suggestions that you may have in the comments and we will try to see if we can implement them. Same goes for any questions that you may have regarding the tool or acoustics in general. Bye bye.